All right, hello once again. This is Jeff Scott of Rankin Technical College. We've been talking databases. And when I left off in the last lecture, I had done this query right here. So I'd like to explain the query before we go on. All right, the first thing I want you to notice is notice how this says E dot, E dot, E dot, C dot, C dot, C dot. Those are called aliases. I could have written employee dot first name, employee dot last name, employee dot address, zip city state dot city, zip city state dot state, and zip city state dot zip. It's a lot of typing to do. So what I did was I gave the name of each one of those in there. I gave the name of each one an alias. I called employees E and I called zip city state C. All right. Hopefully that makes sense. I also gave aliases for the names because I wanted it to look a little bit more professional. So you can see now we've got capitalization for each one of our headings. All right. When I did this the first time and I just said from employees E, comma, zip city state C, and I didn't put the where clause in, as you noticed, we got 48 different results back. Because what it did was it combined each one of the 12 names with each one of the 4 cities. 12 times 4 gives you 48. Because I didn't put any criteria on it. But what I did in this last line here is I created what's called an equijoin, which said I only want to do this where the zip code that's in the employees table is the same as the zip code that's in the zip city state table. So in other words, I wanted to make sure only when this zip code here matched the associated one here. This one matched this one matched this one, etc., as you can see. So only give us matches. Now, most of the joins that you do in this, what I just showed you was a relational database management system join right here. Most of the joins that you do will be equijoins, where you're using an equal sign here. But you can have non-equijoins. In other words, it wouldn't have made much sense here, but I could have used not equal, or I could have used less than or equal to, or greater than or equal to. But again, the majority, the heavy majority of joins that you're going to do like this will be equijoins. All right, that got us started here. Okay, I'm not going to go through, but again, there's 4th normal form, 5th, 6th, 7th normal form. There is Boyce Codd normal form, etc. So there are a lot of these that can be used. All right. So let's break it down a little bit. The first, there's 3 basic types of relationships that you can have in a database. And the first one is what's called a one-to-many relationship. And actually, for lack of better words, that's the nirvana of relational database management systems. And what I mean is that's what you should strive for, is to have all of your relationships be one-to-many. The one side is oftentimes called the parent. The many side is oftentimes called the child. All right, they go by other names too, but that one will suffice for what we're talking about. And they give an example here. Suppose that each product has one supplier, and each supplier supplies one or more products. All right. Then, as mentioned here, we could make our own table that was a supplier's table that just had the supplier ID, the supplier name, and the supplier phone number. Why they used 8 digits for a phone number, I don't have a clue. All right? So that's what the author is talking about here. So to relate the suppliers table to the products table, we add a new column into the products table, and that is this supplier ID, which is the primary key from this table, gets added into this table as what's called a foreign key. And what that means is the only reason for adding this new column into this table is so that we are able to directly relate this table with this table. So if somebody says, hey, I want a list of your names, let's say, the quantity, the price, and the supplier name, we have to get the information from two different tables. All right? So the author comes through here and says, well, let's do this. Let's create a new table. All right? So I could go and type all of this stuff in. I'm not going to do it, though. All right? I'm not going to type all this in just because of the fact that it'll take too long. And why would you want to sit and watch me type? So I'm going to first say use, as you know, because we're using Southwind. All right? And I'm going to actually just copy this stuff in. All right? So I've done use Southwind, drop table if exists, some suppliers. Normally I wouldn't copy it in right from this document, but I'm going to try it and see if it works anyway. All right, that was fine. And then we're going to create a new table. Copy that in. That looks fine. So now if I show tables, you'll notice I now have a suppliers table. That's what I just created here. There's no data in it yet. So if I select star from suppliers, it should come back with the empty set. And it does. Okay. But we have a suppliers table now with an ID, which is our primary key. All right. It can't be null. It's an auto increment unsigned integer. We've got our name, which is a varchar, a variable length name, which defaults to the empty string. We've got our phone, which is 8 characters, which defaults to the empty string. And again, the supplier ID is our primary key. So then we come in here, and I just did describe it for you. So we're going to throw in these, and that should result in this. So let me copy in this. So now when I select star from suppliers, you see that I get those 3 suppliers. The ABC Traders, the XYZ Company, and the QQ Corp, which is exactly what I get right here. Now what I want to be able to do again is I want to be able to take this table and directly relate it with this table. I currently cannot do that because I do not have a field in common between the two tables. So I have to add a new supplier ID field to this table. All right, that's the most natural way of doing this. So to do that, I'm going to say I want to alter the products table, and I want to add a new column, and to do just an add column adds it at the end. It's going to be supply ID int unsigned not null. Where did we get the int unsigned not null from? We got that from right here, int unsigned not null. We don't make it an auto increment. It's a foreign key, not a primary key. So I'm going to right mouse click and copy this. Okay, so let's describe our products table right now. There it is. You can see that it has in it what? It has 1, 2, 3, 4, 5 fields in it. Product ID, which is our primary key, product code, name, quantity, and price. But there is no name in common between this field and the field in our other table. Okay? I don't know what happened here. But something must have. Copy. Now when we come in, let's again describe products. And notice that rather than 1, 2, 3, 4, 5 fields, we now have 6 fields. We have the supplier ID in here now. So if I come in and describe suppliers, now we've got a supplier ID in here and in here. It's a foreign key in this field, or it will be. All right, and it's a primary key in this field. All right. So the next thing to do is to add the foreign key constraint. All right? But it says before we add the foreign key, we need to set the supplier ID of the existing records. So in other words, if I right now come in and say select star from products, notice the last field, it's all set to zeros because we have not set the supplier ID, and we have not set the supplier ID because of the fact that we previously didn't have a supplier ID. All right? So the author says, let's come in here and update products. and set supplier ID equal 501. All right, so they're setting everything to supplier 501. Maybe not the best idea, but it's okay to do that. All right, at least we'll have something in there. So now, when I do this and I select star from products, notice they're all supplied by supplier ID 501. All right, that's okay. For right now, at least, that's okay. We can always go back and change it later if we want to or need to. Now we can alter our products table and make that a foreign key. So notice right now in our products table, we have a supplier ID, but there's nothing special. It's no kind of key. So we're going to come down here and we're going to alter it, and now we're going to run that again. We're going to describe products, and now notice it says MUL, which means multiple, which means that it is now a foreign key. Now the idea of foreign key, pun intended, I guess, is foreign to a lot of people. It's hard for them to wrap their head around. All right? So again, imagine, and I'm going to keep this real simple. All right? This is going to be database, but not a real database example. Let's suppose I have two tables. All right? So here's table 1. And table 1 has field 1, field 2, field 3, field 4, and field 5. I'm just making this up. It means nothing. And we have table 2. And table 2 has field 6, and it has field 7. Let's just leave it at that. And what I want to do is I want to make a query that gives me fields 1, 2, 3, and 7. As of right now, I cannot do that. So let's suppose that this field right here is our primary key in this table, and this field right here is our primary key in this table. And what I want to set up a query that returns field 1, field 2, field 3, and let's just keep it simple, and field 7. That's what I want to do. Right now, I can't do that directly because I do not have a field in common between these two fields. All right? So I've got two choices. I can either take the primary key from this table and copy it into this table, or I can take the primary key from this table and copy it into here. Normally what you do, all right, is, for instance, if I have, let's say that this field right here represented employees. Make it something a little more, something that people can probably understand better. And this table here is departments. All right, and instead of these names that we have here, let's call these employee ID. We'll call this first name, last name, and again, I'm making this up, but I'm going to put in here right now address, and we'll just, for now, we'll just say city. Maybe this is a dumb example. In fact, let's put zip. That's fine. And this will be department ID, and that's, again, the primary key. And this will be the department name. All right? So let's say that I come in here and I decide what I want to do is I don't want two tables like this. I just want to put in here at the end the department name. Could I do that and not even have this table here in the blue? Of course I could do it. But I'd have a lot of repetition as far as the department names. So let's say that one of the names in the department table was accounting. All right, would make sense at a company. But sometimes people put in, instead of accounting, ACCTING. So now I've got people who work for the same department, but they're in there as two different names. So department name probably wouldn't be the best thing to put in there. So let's say instead of department name, I decide I'm going to put in here department ID. All right. Now let's suppose that when I set this up, let's just say 1 equals IT, 2 equals accounting. Let's just say we have 3 departments, and 3 equals shipping. All right. So now I want a query that returns what? The employee ID. Well, do we really need that? No. So let's just keep it simple. The first name, the last name, and let's say, just because we want to keep it real simple, the department name. That's pretty easy. So I want these 2 fields from the employees table and this field from the departments table. Now, because I've added the ID and I have it in each table, I'll be able to write a query that looks something like this. Select employee, no, first name, last name, department ID. No, we want the department name. All right. From the employees table and from the departments table. Now, if I do it like this, I'm going to get one of those Cartesian product joins. So if I have 100 employees and I have 2 departments, or 3 departments, I'm going to get back 300 records. I don't want that. All right. I only want 100 if I have 100 employees. So I'll say here where employees, the employees dot department ID is equal to the departments dot department ID. And you'll notice in this case, I didn't do any of that aliasing that I talked about before. In other words, I could say here E dot, and D dot. And I could have said employees E, departments D, where, and then here I would have said E dot this equals D dot that. There are many, close this. There are many full-time database people who would do this. This is called fully qualifying your names. But what I want to get across to you is this department ID was added to this table for the sole reason that I wanted to be able to relate these tables. And could I have taken the employee ID and put it in this table? I guess so, but that would have been silly. This relationship is one to many. Every one department will have literally 0, 1, or more employees. Why 0? If it's a brand new department, maybe you just did a company reorganization, you might not have anyone working in that department yet. But that would be a one-to-many relationship. So you typically take the primary key from the one side and add it to the many side as a foreign key. Well, that's what I wanted to show you, and that's what I've done. All right, so with all that, let's jump back to here. Okay. So they want to add a couple more of these. So they want to set 502, and it looks like right now they're not going to do anything with 503, but that's fine. So let's go look at our data again. So let's select star from employees. Not employees, I'm sorry, products. All right, so let's grab just some of these randomly. So let's update products. and we will set the supplier ID equal to 502. And again, I'm picking these out randomly, so I'm going to say where the product ID is in. Remember that we can put a list now in here. So I'm just going to grab some of these. Let's say 1005, 1008, and 1000 or 2000. How about 2003 and 2004? All right. And it says we found 4 matches. So notice they're all 501 here. But when I run this again, now I've got 1, 2, 3, 4 of them that are 502. Okay? So notice, again, I want to make sure you understand this. We have 11 products, and we have, where are our suppliers? 3 suppliers. So right now, if I try to combine these, so let's say that I want to come in here and I want to write a query. So I'm going to say select product, I'm just the name. Select the name, the quantity, the price. If I say from products, comma, suppliers, what I'm telling you is what I think we'll get back is 11 records times 3 records. So I think we're going to get 33 back when we do this. That isn't what I want. What do we have here? Name is ambiguous. So I must have name in, do I have name in both tables? I guess so. So let's come back and select. We'll do it like that. We'll say here, P dot name, and we're also going to add here S dot name. So it'll give me the supplier name also. Okay, that's fine. Unknown product, P dot name. So what is the name? What do I have in the applied? There's my product's name. There's my supplier. And my supplier, that was also called name. Oh, I know what the problem is. Okay, let's fix it. Select P dot name, S dot name, price. That's fine. In fact, let's fully qualify. So the product name from the products table, the supplier name from the suppliers table, the quantity from the products table, and the price from the products table. All right, so we'll do all that from products, but we have to say P, suppliers, S. Now I think we should get, 36 records back, or 33, and we do. 11 records from the products table multiplied by 3 records in the suppliers. So I've got every possibility. Well, that's silly. That doesn't make sense. It's actually incorrect or misleading data. So let's run the query again. But we're going to add here where, all right, what field we have in common between the two? It's the supplier ID, where P dot supplier ID equals S dot supplier. Hopefully I put the names in here right. ID. And there we've got it. So now we've got from our products table the name of each product, from our suppliers table the name of each supplier, from the quantity table the quantity of each product, and from the price of each product. Now I can go and use the order by clause to put this in any order I want. Let's just do that very quickly. I think we're getting up there on time again. Yes, we are. So I'm going to run this query one more time. All right, but I'm going to say here order by, and let's order it by S dot name, and if there's any matches, then we'll say P dot name. How's that? So now notice I've got all my ABC supplier or traders together in alphabetic order, followed by my XYZ in alphabetic order. Okay? And that's pretty much what they showed in here. So I can also add other conditions in here. So let's add another condition. And then we'll put this lecture to rest, so to speak. All right, select from where, I don't want that, so I want, where, in fact, let's put here, and the P dot price is less than $1. All right, and I want my same order by in here. Order by S dot name, comma, P dot name. So now notice I don't get all 11 rows as I did before. This row should be gone, this row should be gone, this row should be gone, and this row should be gone, because I asked for just the ones that were less than $1. All right? And that's what the author is showing you in here. All right. Now, this is a database diagram. I'm going to start the next lecture by talking to you about what a database diagram is and what it represents.